techniques that basically, based on from the same client IP and events occurring before and after the event in question for that client IP address, we're able to infer who the user was, and we end up being able to attribute about 85% of the events as a result of that. The final thing we did before we had a data set ready for doing some analysis on was what we call segmentation. A lot of times a user does something very simple in the user interface. They do a search on their shared drive for star.doc. Well, what happens is a series of recursive directory lookups based, the number depends on how high up in the directory structure they are and how deep the structure goes. But those are all really one event. So we create meta events to compress those many single events into a single event. So let's talk a little bit about what events are. This table shows you what we're talking about. The column starting from the second on out to the end there below the actions row lists the types of events that you have, things that you would think about that you would do with a file, reads, writes, lists, deletes, moves. We also had events related, printing when you print a file, queries when you submit a search engine query, and then send is sending an email. The purpose for capturing email, who people send email to, was to establish people's social network. What we found we could do is we could tie information to people, and then if we knew who was in someone's social network, we could look for people browsing outside their social network as a possible behavior of interest. So we collected a lot of data. As I said, we did it at Mitre, and we ended up collecting a very large data set. Raw data-wise, it was about 16 terabytes. Packet-wise, about 100 billion. After filtering, that was reduced substantially. And after basically attribution and filtering and anonymization, we ended up with about 64 million events, and that's for about 4,000 users and this is behavior on our internal network only. And this spanned a period of 284 days. Now, of course, one of the challenges here is we don't know ground truth. Was there truly bad people in there? Well, we don't know. But we considered this background data for purposes of doing some testing. So what we needed was to be able to generate some known positives to at least to use with this data, and we'll talk about that in testing in just a second. In terms of context, I just wanted to throw this slide up. This is what I mean by context. It's information about where users are physically located, their job title or role, organizational membership, perhaps projects they work on. We also found that the information metadata can be helpful. We're not talking about document summarization or things like that, but sometimes just simply the path to a file in a shared drive tells you a lot about what organization probably owns that. In fact, the directory structure looks a lot like org charts oftentimes. And you can use that kind of data. We also did profile user behavior. We had a number of anomaly detectors that were based on profiling the user's behavior over varying time scales. We not only used the user's individual past behavior, in some cases we used peer comparisons, although we found that a little difficult. In some cases you had to be judicious in that. And we also based their behavior upon comparing to the overall organization's behavior over a period of time. And then finally, the context, some of the easy stuff is organizational norms. It's some low-hanging fruit in terms of things that you can look for. Every organization has things that are not specified in policy, but people generally know you shouldn't probably do it. There's probably certain search terms at every company that you probably shouldn't enter in. Or maybe there's an expectation that people will work during core hours and people will not come in the middle of the night to do interesting things. So let's talk a little bit about going from the events to the alerts. We built 76 different detectors, and these were all based on hypotheses where from reviewing past case studies. Every time there's an insider threat case and there's a legal case brought forth, there is a charging document or indictment. It doesn't go into great detail in terms of what the user did, but it generally gives you enough idea to begin to understand what they must have done to do what they did. We supplemented that with the advice of some domain experts who had been working in this area within Mitre. And we also informed ourselves with the events that we actually, the data that we saw in the database. A lot of times we would hypothesize things that we simply found a lot of people did. There was a benign common explanation for that we had to dismiss. Again, these detectors combine activity and context. There's 3 examples there that look for different types of things that we look for. The first one is an example of just violation of organizational norms, maybe terms that you shouldn't be searching on. Excessive printing is an example of where we're using, in this case, we're using, I believe, a folded normal estimator to kind of look for low probability occurrences in terms of their printing behavior based on their past. And this is a volumetric anomaly, another type of indicator that we looked for. And finally, non-local printing. Most people print to printers nearby them. They don't want to walk too far to get to the document. Malicious insiders, if they have coworkers that notice what they print, might not want to print to something that they shouldn't be printing at a printer close by. Why not the printer down the hall, the next floor up? You know, they made a mistake. It's easily explained, but yet it helps them achieve their goal. And there's a lot of permutations to all those different types of things. For all these detectors, we had subject matter experts that basically helped establish the settings. For the detectors and the BaseNet settings as well. The BaseNet itself, we experimented around with a lot of different structures and ultimately settled on a fairly simple structure. At the root node, you have the probability that they're a malicious insider. Beneath that, you have what we call the behavioral layer, and really these are things where you're thinking about what's the probability they will engage in behavior 1, 2, 3, etc., given that they're malicious, or what's the probability that they engage in it given that they're not malicious. To populate these conditional probabilities, we basically gathered groups of subject matter experts and elicited from them probabilities to try to get an idea of and sometimes it was quite time consuming and challenging, but they ended up doing a lot better than they thought they would do. And then finally you have the detector layer, and what's the probability of a detector alerting given that the behavior occurred. And this was done with a combination of assumptions in terms of detection and some empirical measurements in terms of false alarm rate. You know, was there some overlap in terms of how we built, you know, was there strict independence in terms of, you know, Bayes networks, you know, the theory you should have independence between, you know, the nodes. No, there was some dependence, but, you know, we found, we also know that, that Bayes networks can be somewhat tolerant of that assumption being fudged a little. So what you get out of the Bayes network, you introduce evidence in the form of alerts for each of the detectors, either a binary 1 or 0. What you get out is a threat score between 0 and 1, and what you get is a folded normal, highly skewed distribution that's shown in the graph on the upper right on the graph, view graph. And what you see there are the threat scores sorted from high to low for all the users in the environment monitored, which is about 1,500 users for a day. If you're an analyst, you're very happy now because you see few people with high threat scores, and most people get little to no threat scores. So at least now you have some sense of triage or how to prioritize what you look at. And of course, this is only valid and good if, you know, when you actually have bad people, they show up near the top. So let's talk a little bit about how we tested. As I mentioned, well, as I said, we don't know ground truth of the background data. So we did make the assumption that the background data had no malicious activity in it. And we basically had a separate team develop a set of scenarios to have red teams run over the period of time during our data collection. They basically looked at open source material on known inside